All right, welcome back. So the last sort of week, I guess last week, we were looking at regression, and we were looking at sort of figuring out whether or not we can trust the overall model, right? So in this case, we've got a fairly decent model that I've just randomly drawn here. There's not a lot of over or underestimation going on, at least in one sort of localized spot, it's not. So if, though, the residuals, no. If our model, or if we had data that kind of looked like this, where, let me do it a different color. Okay. Where in this case, you've got, you've got a lot of kind of clustering down here, but then a ton of over and underestimation going on over here, right? So locally, this place is not great, but here it's doing a pretty good job, right? Well, then the residuals, that distribution of the residuals would look something like, let me see here. Yeah, the distribution of the residuals would look something like this. Something like that, kind of. Okay, and when it's still centered at 0. That's not great. And I have not given you an example of that in this class for two reasons. One, because that's, if you take stat 3050, you do learn how to remedy that. And then the second reason is the remedy is, kind of outside the bounds of this class. Whoops. But what you would do in this case is that you would log transform. At least that's the first thing that you would try, right? So you would take some x, good lord, you would take some x value and some y value. And what you would do first is that you would just take the log of all of the x values, right? And that might then spread out everything. And if that didn't work, then you would try the log of the y values, leaving the x alone. And if neither of those looked good, then you would take both the log of x and of y. I guess if we're being specific here, lowercase. Okay. But anyway. But then that changes the overall interpretation, right? If you were to take the log of x or y, or both, instead of saying for every 1 unit increase in x leads to some change in y, the slope coefficient, you would then have to say for every percentage change in x leads to another percentage change in y, at least in this case, right? And that just gets to be very confusing very quickly. So that's beyond the scope of this class. And then that's that. But that is sort of the first go-to of making the residuals look better. So a few of y'all asked that, and I'm very happy that you did, because that just tells me that I'll probably see you again in the next version of this class, the next kind of step up, which is sweet. So with that, we'll just leave it. We'll leave it there. If you have other questions, if you're curious, then let's chat and we can talk about it then. All right. Next loose end in just a second.